So imagine you're sitting in your room drawing a picture. You start with a girl. She's standing outside, so next you draw the grass, the sun, and the clouds. But it's missing something, so you decide to draw flowers. You start with the roses, which are easy. But when you try to draw a daisy, the petals get all messed up. Some are too big, others too small, and they don't seem to fit together right. So you think to yourself, there has to be a way to draw a flower with uniform petals. In math class you learned about graphing, but only things like lines, parabolas, and circles. I guess you could draw a flower by connecting multiple circles together, but then you're left with a weird gap in between the petals and the center of the flower. It turns out that you can draw a flower using math and graphing, but not in a rectangular or XY plane. Instead, you need a polar plane. On a polar plane, instead of using the coordinates xy, you use r theta. It's also easier to graph on a circular grid than a square grid. On the graph, r is the distance from the center, and theta is the angle from the starting point, 0 degrees. So this point would be 345, because it's 3 units long and at a 45-degree angle. But what now? You think back to math class and learning about angles, triangles, and SOHCAHTOA. SOHCAHTOA! Sine, cosine, and tan all had theta in them. Maybe we can try graphing these. Let's try r equals sine theta first. We make a table of values for different angles of theta, then using our calculator or unit circle, we can solve for r. Then all we have to do is plot the points and connect the dots, and, well, it looks more like a circle than a flower, but we're getting there. So if that didn't work, let's try adding in a variable. If we look at the equation, we could add in a constant in 2 places, in front of the theta or in front of the sine. If we add in a 2 in front of the sine, make a table, plot the points, we just get a bigger circle. So what if we add in a 2 in front of the theta? Again, we make a table, plot our points, and hey, it worked! We have a flower with 4 petals. So what about r equals sine 3 theta? Maybe since the graph for r equals sine 2 theta had 4 petals, this one will have 6. Or 3. That's weird. So what is the connection between the constant and the number of petals? If I want a flower with 8 petals, what constant would I use? I guess if we wanted to figure this out, we could make a table for different values of the constant and the number of petals we get when we graph that equation. We know when b equals 1, there is only 1 petal. When b is 2, there are 4, and when b is 3, there are 3 petals. So let's try r equals sine 4 theta. We make a table, plot the points, and get a flower with 8 petals. When b is equal to 5, we get 5 petals. And for b equals 6, we get 12 petals. Let's look at our results. Whenever b is even, the number of petals seems to be equal to 2b. But whenever b is odd, the number of petals is equal to b. Why is this? Where did the other half of the petals go when b is odd? If we look at how we graphed r equals sine 3 theta, some of the points on our graph overlap. For example, when theta is 45 and when theta is 225, the point in the same spot. It turns out that if we trace the graph from theta equals 0 to theta equals 360, the petals overlap as well. So we're actually drawing 6 petals, we just can't see the second 3. So now that we know how to draw flowers with any number of petals we want, the next question has to be, what do I do with all these flowers?